Okay, so different measures of spread that we're going to talk about. We're going to talk about the standard deviation, but first we're going to talk about the range. So the range is really a simple measure. So it's just take the highest value minus the lowest. So here the range would be 6. Okay, not too crazy. Okay. But that's not such a good thing, because what I'm going to do is we'll call this problem A. I'm going to put a problem B up here. And so like if I had a set of data where there's 2 2s and 2 8s, you know, those sets are different sets. So I'm going to just kind of draw a picture of it right here. Like, so the first set, I've got a 2, I got 2 3s, and an 8. Okay? Well, this set, if I made it like this, I have 2 2s and 2 8s. So really, we have a clump of data here and then one outlier in this set, in set A. In set B, we have it like totally separate. There's 2 on the left and 2 on the right. So it's really kind of like different sets, but really they have the same range. Okay, so the range in each of them is 6, but it really doesn't really describe the spread. Okay, so one of the things about the range that's nice is it's quick. Okay, so an advantage of the range is that it's quick. Okay, a disadvantage is it doesn't use all of the values to calculate that range. So the method that we're going to talk about is going to use all of the measures when we calculate the measure of spread, called the standard deviation. So again, what this is saying, can you guys read that? Advantage, this is quick. Disadvantage is that it doesn't use all values in the calculation, right? Just use 2 values, the low and the high, right? So what we're going to look at is we're going to actually look at, now don't get this confused. Don't get standard deviation confused with deviation, okay? So the deviation of the set is going to be the value of the set minus the mean of the set. So like first we need to calculate the mean. So if I calculated the mean here, I add them up and I get 16, right? 16 divided by 4 is 4. So the mean of the set is 4. Okay, so I'm just saying for now that this is a population. This is a 4-item population, so this is the symbol for mean of the population, right? So the mean is 4. So what's the deviation of 2? 2 minus 4 is negative 2. So deviations can be positive and negative. So we got 2 minus 4, 3 minus 4, 3 minus 4, and 8 minus 4. So this one is 2 below the average, this one's 1 below the average, this is 1 below the average, and this is 4 above the average. So deviations are just like the distance from the mean, okay? Okay, what is the sum of the deviations here? What do you get if you add these up? Negative 2 plus negative 1 plus negative 1 is negative 4 plus 4 is 0. And it's always going to be 0. So if you want to check to see that you've calculated your deviations right, make sure that you calculate the sum of the deviations, and then it's always going to be 0 in every set. So that wouldn't really help us figure out what, you know, the deviations are. Like, what's a typical deviation? Okay, so what we do is there's other ways of doing it, but what we do is we actually take the deviations and we square it, because what happens when you square a number? It's always going to be a positive. So this is your deviations. So let's take that deviation and let's square it. And so 4, 1, 1, 16. So now that's not always going to be 0. That's always going to be a positive value. Okay? So we call this the sum of the squares. What's the sum of these squares? What's the sum of the squares? Well, it's going to be 4 plus 16 plus 2 plus 2, 22. So the bigger that gets, the higher the deviation would be in a set, right? Well, here's what we're going to do. We're going to calculate the population variance. The population variance, symbolized by sigma squared, is the sum of the deviations squared, the sum of the squares, right here, right? This number divided by n. So what is n in this case? Take a guess. 4, right? Because capital N is the size of your sample, or the size of your population. The size of your population is 1, 2, 3, 4, right? Okay. So divide that by 4, you get 5.5. So the variance of this set is 5.5. Now, look at this guy here. How is this guy related to this one? Well, this is the square root of this. Okay? So if you want to calculate something called the population standard deviation, all you're really going to do is take the square root of the previous value. So like, look at the formula here. The only difference between this guy and this guy is this has a square root. Okay? So this is the symbol for standard deviation. This is a Greek letter sigma, lowercase s. Right? That makes sense? Sigma, standard deviation, S, 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 right? Okay? So you just take what you had before and you do what with it? You take the square root of it. So the standard deviation of this population is the square root of 5.5, which is 2.35. So what is that a measure of? That's a measure of spread. Okay? It's not an average, but it's a like measure of how far the values are from the mean on average. Okay? It's kind of an average. So like, look at the deviation here. If you ignore like the sign, how far is it from there to there? 1, 1, 2, 4. Right? So the variation, if you again ignore the sign of it, is about 2.35. So that's a way that we can look at the typical spread that those values are from the middle. Okay. What do you think the standard deviation of this set is in relationship to this one? What would you guess? I want to tell you that the average is going to be 4. Let's see here. 1, 2, 3. That's 3. 3, 3, 3. Guess what the standard deviation of that set is? Guess. Jackson, you're a good guesser. What do you think the typical distance from the mean each of these values are? 3. Okay, so that's what standard deviation is. It's a typical distance from the mean of the distribution that each value is. Okay, and again here it would be 3. So let's calculate. You guys do this one here. Okay, so I'm going to put it on the whiteboard for all of you fans listening. Okay, but if you take 2, 2, 8, 8, first off, I'll verify that the average is 4. So if you add these up, 16 plus 4 is 20. 20 divided by 4 is 5. So the average is 5. Okay. So now what would you do? You would calculate, what's this formula of? This is the what? Deviation. So 2 minus 5, 2 minus 5, 8 minus 5, 8 minus 5, negative 3, negative 3, 3, and 3. Now, I rewrote it over here, okay, but you don't need to. What you would do next is you would take the deviations and you'd square it. So square of that, 9, 9, 9, 9. Then what do? Add them up. So that would add up to 36. Formula for the standard deviation is the square root of the sum of the squares, right? What's the sum of the squares? Squares, sum is 36. So we take 36 divided by 4. So that would be the square root of 9, which is 3. So the typical standard deviation, or the typical deviation that each value is in that set is 3. A little bit more than the previous one. Okay? So that's what we're measuring. We're measuring typical spread from the middle. Okay? Give me a question. Don't be afraid. Now, are there going to be ways that we're going to calculate this later in the year that don't involve doing it by hand? Yeah, but right now you're going to do it by hand. Okay. Now, the problems that I give you today, what you're going to do is you're going to calculate the sample standard deviation. So that's what we're going to talk about now here. We're going to talk about the sample standard deviation. So the sample, if the data is from a sample, is right here. There's not much difference. We use S instead of sigma for the symbol. We still have a square root. Tell me the differences. What's the differences in the formulas? Well, clearly the denominator here is n minus 1, right? That's different. Now, is n and little n, they're really the same thing, okay? But we divide by n minus 1, and I'll talk about why that is another day. I'm not going to talk about it right now. And then the other difference is that we take and we subtract the data minus the sample mean. That would seem appropriate if we're working with a sample, right? So we subtract the sample mean from x instead of the population mean, because this isn't a population, and we're doing a problem using this formula, okay? So that's not much different, okay? So what I'm going to do is I'm going to give one half of the room one problem, and one half of the room another problem, and I'm going to have you guys calculate the sample standard deviation, okay? So let's go with this half of the room is going to do the sample standard deviation for this set. This half of the room use this data. So each of you have 6 pieces of data. I'll even tell you that the means of both of them are 10. Okay? So see if you can calculate the standard deviation. So you should write down the data. You should write down the deviations of each. And then what should be the next column? The squares, right? So the deviations squared. And then add them up. See what you can get. So just kind of looking at each of them here. Just as a quick review here, what is the sum of the deviations always equal to? 0, right? So you can check that before you go on, right? So the negatives add up to -10, the positives add up to 10, so this would add up to 0, right? So that's why we have to square it so that they're not adding up to 0, so they're all positive. So 16, 9, 9, 0, 0, 100. So what goes right here? Right, so it'd be the sum of all those values right there. Okay, so 134 divided by 5. And so what do you get for the standard deviation of that set, anybody? Right. So like one question that people have, and I should have explained this maybe better, is like, how far should you round it? Well, you should go one more decimal place than the data. So I would say 5.2 at least. We'll round to the 10th. Right, if the data is to the ones, then round to the 10th. Okay. Over here, let's check this out. The negatives add up to -3. The positives add up to 3. So we have a deviation, a sum of those being 0. You add all those up, and that would end up being 8. Right? So we got 8 divided by 5. Everybody understand that that's one less than the number in our sample? So 6, so 5. We'll talk about why that is later. If you work it out, you end up getting about 1.6. Is it 1.6? Okay. So, but then you got to take the square root of it. So this is 1.6, but then you got to take the square root of it. So I think that the standard deviation is 1.3. Okay. So what does that tell you about the data? What does that standard deviation of 5.2 compared to a standard deviation of 1.3 tell you about the data? Right. So the typical spread here is more than the typical spread here. Those distances on average are less than the distances are over here. Okay. Let's do one final thing. Okay, so looking at the formula, I'm going to number what you do first. Okay, so what's the first thing that you would have to do in using this formula? You would have to calculate that, right? You'd have to calculate the mean. So that'd be the first thing. What would the next thing be that you do? You would calculate this column, wouldn't you? You'd calculate the deviation. So you would do this next. What would you do next? Square them. So this would be the third thing. Then what would you do? Add them all up at the bottom. So that would be this here. And then you would take that numerator, divide it by this, take the square root. So then you just follow. It's really, what I'm saying is you're following the order of operations. You do brackets, squaring, find the sum of the numerator, then divide. Maybe I'll put that as number 5. And then this square root is 6. Okay, so that's your formula. Okay, and it kind of tells you the order that you do it in. Okay, so let me stop this video, and then I'm going to give you a note card here.